Hello everyone, Mr. Fawcett here, and we are back with another geometry lesson. Today we're going to talk about an extension of congruent triangle proofs. So we've already talked about how to prove triangles congruent. We've learned the shortcuts, all 5 of them, and now we're going to extend our proof. So we're going to go past just proving the triangles congruent. There's other stuff we can prove once we know the triangles are congruent. Before we get going though, let's do a couple of warm-up problems, number 1 and number 2. Pause the video, take a couple minutes to do them, and then join us back for a discussion. All right, so number 1 says, if triangle ABC is congruent to triangle DEF, then angle A must be congruent to what angle? Well, we just match them up. What's the corresponding angle with A? Well, that's going to be D because it's in the first position just like A. And side CA, so that's the first and the third spots, is going to be congruent to side DF, or you could say FD. Either way, it's okay. They're segments, so the order that you name them in does not matter. Number 2, it says if angle 1 is congruent to angle 2, why is A parallel to B? Those are the 2 lines. Well, let's think about what theorem we can use. If we're given that the angles are congruent, and we need to know what kinds of angles, right? Those are going to be alternate interior. So the alternate interior angle theorem says if 2 lines are parallel, then alternate interior angles are congruent. But we want to go the other way. We want to say if 2 alternate interior angles are congruent, then the lines are parallel. So we're going to use the converse of the alternate interior angle theorem. Or angles theorem, rather. Okay? And let's move on to our new thing for today. Cpctc. You can try to say that 10 times fast. Cpctc stands for corresponding parts of congruent triangles are, man, I cannot spell congruent today, are congruent. So you will be able to use that shortcut in a proof, right? You'll just be able to write Cpctc, but we have to know what this stands for. So it's corresponding parts of congruent triangles are congruent. And all that means is that if we have proved 2 triangles congruent, we can also prove that the other individual sides are congruent and the other individual angles are congruent. So real quick example. Let's say I have triangle A, B, C and triangle D, E, F. And I know that these corresponding sides and angles are congruent. Well, I could say the triangles are congruent, right, by SAS. They fit that shortcut. But after I say that the triangles are congruent, I could then go ahead and say that these other sets of sides and angles are congruent. So I could go ahead and say that side AC congruent to side DF. I could say angle C congruent to angle F. And then I could also say angle D is congruent to angle A. So Cpctc lets us then prove that other parts of the triangles are congruent once we've proved that the entire triangles are congruent to each other. So that's what this says right here. In order to use Cpctc, you must have already proven that you have congruent triangles. So this can only come after a shortcut, or after we have already proved that we have 2 congruent triangles. All right, let's do some practice. We'll do some proofs as well as diagram problems. Take a minute or 2, pause the video, see if you can do parts A and B on your own before you come back and listen to a discussion. All right, so it says, what theorem or postulate can you use to prove that triangle QPS is congruent to triangle RSP? Well, let's outline one in red. I'll outline the other one in blue. Now they share two sets of angles, but that's not good enough, right? We need at least one side. So we can also see that they share this middle side, PS. So in this case, we would use AAS. Right? The side is not between the angles, but we do have two angles and one side from each triangle. Now, once we know the triangles are congruent, I can go ahead and prove all the other corresponding sides and angles are congruent. And I could, probably the easiest way is to use this statement right here, right? So let's say angle S from the blue, and maybe I'll color coordinate it so it's makes sense, right? This is the blue. This is the red. So I can say angle S from the blue is congruent to angle P from the red, because those match up. Then I could think about my sides. Let's do side PQ from the blue. That is in the first and second position. So the side from the red would be RS. If I do my other set of sides, I have side PR. Well, that's from the red. What am I doing? I have QS from the blue. First and third positions. And then I have side RP from the red, first and third positions. So we would be able to say that all these are congruent using Cpctc after we have proved the triangles congruent to each other. Let's see how this works out in a proof. So I'm going to let you work it out on your own first. Take a couple minutes and then join us back for a review. All right, so it doesn't specifically state the given here, right? It doesn't state it in symbols. However, the diagram does have some tick marks on it, which would count as given, right? Because you didn't put them there. They were already given. So we know that two sets of sides are congruent. We can write that as given. And this would be two little s's, right? Then it says our next reason is going to be the reflexive property. And this is going to be of congruence because we are working with congruent statements. I know you already have that fixed on your paper. So we need to be looking for a side that is common between both triangles, right? And that's going to be that side RP. So if I have a blue triangle, and I have a red triangle, they both share side RP. So I could put 3 tick marks there and say that RP is congruent to itself. You could, of course, say PR is congruent to PR. And this is another little s. So based on what we have, why are these triangles congruent? Why is triangle NPR congruent to QRP? Well, the shortcut we're using is SSS. So now that we've proved the triangle's congruent, we are now being asked to show why angle N is congruent to angle Q. Right? Well, this is where Cpctc comes in. Once we have proved that the triangles are congruent, we are now allowed to state that other parts of the triangles that we haven't proved congruent yet are congruent. The corresponding parts of congruent triangles are congruent, the Cpctc. Right here, again, it's just a reminder, we need to take note that we had to prove 2 triangles congruent before we could use Cpctc. Now, there are other things we could prove using Cpctc, right? There are 2 other sets of angles, but the proof didn't ask us for those, so we didn't have to worry about them. But there were 3 other things we could use Cpctc for. All right, let's see what's next. I think we might end with this one, actually. So first one, the proof is already done for you, but you need to go find the error. All right, there's an error somewhere. Take time to go and look at what that error is, and then you need to explain how you would fix it. So what would you add in and what would you take away? All right, so let's take a look at this proof. It looks similar to the one that we had above. We first have two givens. Segment AB is congruent to segment CD. That's marked, and it is given, so that's correct. Then we have segment AD is congruent to segment BC, which is also given, so that's correct. Then we have segment BD is congruent to segment BD. Well, he or she didn't tick the side off. That's okay. It's not necessary. It just helps us. But we could do that. And then they said angle C was congruent to angle C. Well, it looks like those angles are the ones that should be congruent. However, what did that student forget to do, right? They forgot to write their triangle congruency statement. You can't use Cpctc, and they just wrote the entire thing out, but you are allowed to abbreviate. You can't use this until you have that triangle congruency statement. So we can say they forgot a congruence statement for the triangles. So if I get rid of this, not get rid of it, but we need to move it, I need to insert something right here. And I need a triangle congruence statement before I use Cpctc. So we would just need to make sure we match up those vertices correctly. For the red triangle, we'll start with A, B, D. And if I match that up correctly with the blue triangle, I'm going to get triangle C, D, B. And again, you can check that just to make sure the sides that are congruent match up in our congruent statement, but that would be the correct one. So as long as we add that in our proof right before statement number 4, we are good to go. We should actually make sure we have our reason too. This would be SSS, so triple S. So as long as we have that entire statement and reason, we can then use our corresponding parts of congruent triangles are congruent theorem. All right, we are going to stop it here for this video. There's quite a few more problems to do. We will take a look at those in class, or you can feel free to start them on your own. So again, the main takeaway here is that we have a new theorem to use, Cpctc, but we can only use it after we prove that two triangles are congruent. All right, enjoy the rest of your day, and I will look forward to seeing you next time for the last lesson in this unit.